In Calculus 1, it is learned that you are able to integrate basic functions that have something like of f of x in terms of x, and then this would integrate into a f x plus c. Well, now in Calculus 2, through a process called integration by parts, you are able to integrate two functions that are being multiplied by each other. So you can say function 1, we could call it g of x, well, g prime of x, and then we could call this f prime of x. We can multiply both functions by each other. Now this right here, well, we could give, let's just call this right here, let's just say this right here is u. And we can call this whole thing dv. Okay. This right here will break down into uv minus integral of v du. So basically what ends up happening is, so you take your u function, well, the function you nickname u, and you multiply it by the function you get by integrating your dv function. It'll make sense in a little bit. And then you subtract the integral of your v function being your dv integrated, and then you solve in terms of du. This doesn't really make sense right now, but it'll make sense when we show the first example. Alright, let's see. Let's start off with the simple problem. Let's say we have the problem x e to the x dx. This might seem like a complicated problem because you used to be able to just integrate x, or you would just be able to integrate e to the x. Integral of just x by itself, if we were to have integral of x dx, would just be x squared over 2 plus c. But since we don't have just an x alone, and we have a e to the x being multiplied by it, we have to use integration by parts to solve this problem. Let's just write what the general formula is. So it's u v minus the integral of v du. Okay, typically you want to let your u be the one to be easier to differentiate. So the easiest one to differentiate is x, because if you differentiate x once, we just call it f of x. F prime of x would just equal 1. This will make sense in a little bit as to why it's better to choose the easier differentiable function. So we can call u x, and we can say that du is equal to 1 dx. But typically I don't like writing the 1, so I just call it dx, because it's the same thing as saying 1 dx. Alright, we have our v and our dv. We actually work backwards on this one, so we look at our dv, which is e to the x times dx. E to the x times dx. Now what is the integral of e to the x? Or e to the x dx? That would just be e to the x. Now from here, you can just set up your new integral, or your new function. That would be x times e to the x times e to the x minus the integral of e to the x dx. Now you can simplify this a bit further. You can just say x e to the x minus e to the x plus c. We could simplify this a bit more. We could just say e to the x. We can factor out e to the x and multiply, well, not multiply by just factoring out e to the x plus c. And that will be our answer. Green is for the answer, purple is for the question. Now for a problem that's a bit more challenging. Let's say we have the integral x sine of x dx. Alright, we do the same thing again. We try to find the one that's easier to differentiate, and we call it u. So in this example, it is again x. What happens? What do you call x when it's differentiated? You just call it dx. Now we have sine of x. Now this one you have to be a little bit careful. So what is the integral of sine to the x? It is negative cosine of x. One might think it's actually cosine x, but that is incorrect, because if you were to differentiate cosine x, it would give you negative sine x. So the only way you would be able to get a positive sine x is if your cosine was originally negative. Because the reason that is because you have a f of x, right? You have negative cosine x. So if prime of x is equal to negative sine x, and a negative and negative makes a positive. Therefore, that's why this sine x right here is a positive, and then that's why this right here is a negative cosine x. And you cannot forget your dx here, because that would be incorrect. Now let's just simplify this integral down to give you negative x cosine x minus the integral of this one right here multiplied by this one right here. So that would be negative cosine x dx. Now what happens when you get a negative and a negative? You get just a positive and a positive. So this one you could just erase right there. What do you differentiate to get cosine x? Just a regular sine x. Now you just bring this down, negative x cosine x plus sine x, and you can never forget your plus c. And that is your answer. Purple for the question, green for the answer. Now, not all your integration by parts problems will be this simple. Let's do one where it has repeated integration by parts. In this case, it is still easier to differentiate the x squared. You can let x squared be u. Du would be 2x dx. And then v and dv would come from the e to the x dx. E to the x is just the integral of e to the x dx, because when you try to differentiate e to the x or integrate it, it is just basically the same thing over and over again. So let's see. So x squared times e to the x minus the integral of e to the x dx times x and then times 2. I like writing my x in front of my e to the x when it's inside the integral. Alright, now for this one, you have to do another integration by parts, because there's two functions being multiplied by each other. So we could just put this whole thing right here in brackets to make it a little bit simpler to follow. Now for the second one, we could still use the u, the du, the v, and the dv. But we have to do something to it so it's easier to differentiate from these right here. So we can actually tell which one is for the first integration by parts and which one is the second time we apply integration by parts. So for this one, I like to just use a little bar. So u bar, du bar, v bar, and dv bar. Alright, for this one, we could use x as our u, and our dx would be our du bar. Now our v will still be e to the x, because e to the x dx integrated is just e to the x. Now let's simplify this down. X squared e to the x minus 2 integral, oh not the integral, but bracket, and then we multiply our u bar times our v bar minus what is v bar times du bar. We could leave it as this, or we could just simplify this down. Minus 2 e to the x x plus 2 e to the x plus c. Green for the answer, purple for the question. For this one, it's not that we just randomly changed the sign because it here was positive and here was negative. We just mixed it with this negative sign. So that's why this positive and this negative made a negative, because a positive and a negative make a negative, but a negative and a negative make a positive. Alright, for one last problem, we have a bit of a different scenario. So for this one, we're gonna say we have the integral of e to the 2x sine of x dx. Now the thing with this integral is that we have to call it I. This will make sense in a little bit. So we say, let's just set, let's see which one we do. So we let u equal e to the 2x. Now our du would be 2 e to 2x dx. Now our v will come from our dv, which is this right here. This is sine x dx. And the integral of this is negative cosine of x. Okay, now remember this function because it will appear again. Alright, now let's say I is equal to uv integral of v du, because this is a general form of integration by parts. So we have our u, which is e to the 2x, multiplied by our v, which is negative cosine of x. Now we subtract our v, or the integral of v, which since it's negative, I'll just go ahead and make this a positive. So this integral of v du, which our v is cosine of x, and our du is 2 e to 2x dx. Alright, we have to do integration by parts one more time on this part. So let's differentiate it like we did on the last problem. So we can have our u, our du, our v, and our dv, but we have to differentiate it using a bar. So all of these are essentially just the bar version of these original ones. So what should we use for a u bar? what you want to do is you want to keep it consistent from the original one, because it'll make it a lot easier to keep track of, and that way you don't just keep going circles and circles trying to do integration by parts several times more than you actually have to. So we have e to 2x as our u, 2e to 2x dx. Now for our du, we will have cosine of x dx. It's not always the same. Is the du, the dv, excuse me, is not always the one that's next to the dx. It's whichever one makes it easier to integrate, and the other one is usually the one that's easier to differentiate. So in this case, the cosine is easier to integrate than the e to the 2x. Now for this one, our integral would just be sine of x. Alright, so now let's just say I is equal to negative e to 2x cosine of x plus 2 bracket, let's just put a bracket right there as well, uv, which is e to the 2x, multiplied by your v, sine of x, minus the integral of v du of v du, which is e to 2x dx. You might be saying, wait a minute, we already have this over here, and if we keep doing integration by parts, we will just go in circles and circles and circles. Well, that's why we called this right here, we gave it a name, and we called it I. So this just becomes another solving for x problem. So this whole thing right here is just replaced by simple I. So we rewrite this to make it a little bit simpler. So I is equal to negative e to the 2x cosine of x plus 2 e to 2x sine of x minus 4i. Now this, like we said, we're trying to solve for i's, so we have this negative 4 on this side, and we want to get all of our i's on the same side. So this just becomes 5i equals negative e to 2x cosine of x plus 2 e to the 2x sine of x. Now something I'm really realizing right now is I'm forgetting my plus c, but the plus c, it's better to just leave it towards the end once you have your final answer, because essentially you have the unknown, and if you multiply the unknown by it 5 times, it is essentially just saying, is essentially the same thing as saying it's just another unknown, because you don't know what this is. So multiplying, let's just say 5 by 1 is the same thing as 5, which is another constant that still differentiates to 0. That's the reason why we have to put an unknown. So we just get I is equal to 1 over 5 negative e to the 2x cosine of x plus 2 e to the 2x sine x plus c. Let me just double check this. Let me see. I believe I might have mistaken a sign somewhere. Let's see, so we start off with that. Our sign is correct here. So it gives you a sign right there. It gives you negative negative, which is a positive here. This continues to be a negative all the way to the end. So this is negative all the way through. So this part is correct. Now we have to check for this part. Let's see. So we have a negative here, which is negative negative here, which gives you a positive. So we wouldn't have to worry about this part right here. So we have a e to the x. Well, so here we have to choose a new dv and a new u. So this one is chosen correctly, which integrates correctly into sine x. And our sine x is just our v, so this remains a negative. When you integrate a negative sine x, it gives you positive. Wait, oh no, we just left it as an I, so we don't have to worry about integrating itself. So yeah, it just remains a 2 on this side, so it's essentially just a 2i. And this is just negative 2i. So we multiply by a 2, it gives you a negative 4. Because a positive times a negative is a negative. So we have a negative on this side, so we travel it to the other side by adding 4 to both sides, cancels a negative 4 here, and it creates a 5 over here, so that's correct. And this one doesn't have to change because this one is a positive and it's positive here as well. Say positive and a positive gives you a positive. So this one is correct as well. So these two are correct. And this is just basic algebra from here. Add a 5, well, gives you, add a 4 gives you 5. And these are correct as well. So yeah, so this question is correctly written and correctly answered. Yeah, I don't know why on my answer sheet it was differently. So purple for the question and green for the answer. Usually professors want you to box your answers and highlight your problems. And yeah, thank you for watching.